Now come to discuss in detail about the software testing and software testing process. The following topics are covered in detail in this lecture. Program testing. What is program testing? Testing is intended to show that program does what it is intended to do. This means that every program have a specific function or we can say functionality or role. So the purpose of testing is to check or to validate that either the program does for which it was designed or developed or not, and to discover the program defects before it is put into practical use. When you test software, you execute a program using artificial data. This means you test the data or artificial data. You check the results of the test run for errors, anomalies, or information about the program's non-functional attributes. Can reveal the presence of errors, not their absence. This means the best testing will be that discover more and more errors. If we cannot explore or discover any error, this means the testing is not conducted well. So the purpose is not to hide the errors, but rather to discover it. Testing is a part of more general verification and validation process, which also includes static validation techniques. This means both verification and validation are the part of testing. Static validation is a kind of verification before implementation, and validation, dynamic validation. Program testing goals or aim. The goal is to demonstrate to the developer and customer that software meets the requirements. For custom software, this means that there should be at least one test for every requirement in the requirements document. For generic software product, it means that there should be a test for the system feature plus combination of these features that will be incorporated in the product release. The second goal is to discover situations in which the behavior of the software is incorrect, undesirable, or does not conform to its specification. Defect testing is concerned with rooting out undesirable system behavior such as system crashes, unwanted interaction with other system, incorrect computation, and data corruption. So these all are the goals. Validation and defect testing. The first goal leads to the validation testing, where you expect the system to perform correctly using a given set of test cases that reflect the system expected use. And the second goal leads to defect testing. The test cases are designed to expose defects. The test cases in the defect testing can be deliberately obscure and need not reflect how the system is normally used. So the first goal is to validate that either the system works as it was designed for some purpose or not, and the second is to explore more and more defects. So in defect testing, we will give a variety of inputs. We will test the software against variety of inputs, and for validation we will give straightforward data and will test that either a software performs its functionality or not. Validation testing actually demonstrates to the developer and system customer that the system meets the core requirements. A successful test shows that the system operates as it was intended. And defect testing discovers faults, defects, errors, faults in the software where its behavior is incorrect or not in conformance with its specification, or we can say SRS. A successful test is the test that makes the system perform incorrectly and so expose a defect. This means a successful test will be that explore more and more the system. If the system is explored such that it does not perform well or it perform badly, so this means the test is successful. Input output model of the program testing. So this is the in system. We give input test data and output test data are generated as a result. So input causing anomalous behavior and output which reveal the presence of defect. This means this one is actually the validation where we give data and we check the output and check that the functionality is okay or not. And then here we explore more and more defects. Now there are two terms that we often listen. One is verification and another is validation. Now what's the difference? Verification means, are we building the product right in a right way? This means the software should conform to its specification. Or we can say verification is a static process of checking the documents or designing, etc., etc. While validation is, are we building the right product, means the software should do what the user really requires and it is validated using dynamic tests. Aim of verification and validation, V means verification and validation, is to establish confidence that the system is fit for the purpose. Obviously purpose comes from the users in the form of business goals. If the software meets the business goal at the end, this means software is fit, declared as a fit. If it meets the user requirements and business goals, it is fit, declared as a fit. It depends on the system purpose, user expectations and marketing environment. Software purpose, the level of confidence depends on how the critical the software is to an organization. User expectation means users may have low expectation of certain kinds of software. Sometimes the software meets the requirements, the purpose is fulfilled, but the user expectation is not fulfilled. Why? Maybe some non-functional requirements are missing, the design is not good. And then marketing environment, getting a product to market early may be more important than finding defects. Yes, this is a good approach. And then beta test is designed for this purpose, that the product is launched for some duration of time to take reviews from the market, from the users, and we discover early defects. And sometimes not a fully software is deployed and delivered or launched, but rather we launch some features or components or modules, and then after taking reviews we then fix those defects, or we modify the design and laterally then develop more features. Now come to inspection and testing. What difference between these two? Software inspection concerned with analysis of the static system representation to discover problem. It is also called static verification or verification. Static verification, inspection, these lies in the same category, but the organization of the team differs. Maybe supplement by tool-based document and code analysis, and later will be discussed in detail in the testing course. And software testing concerned with exercising and observing product behavior, or we can say dynamic verification. So basically we have two types of verifying the requirements: static verification process and dynamic verification process. Dynamic verification process is also called testing, and static verification process is also called inspection. Now, using inspection method, we can verify statically the specification documents, architecture, UML design models, database schemas, and program. And using testing, we validate dynamically the program during implementation of software or after, or before we can also test the program before the implementation using the system prototypes. So system prototypes are already discussed in your previous lectures, that we have two types of system prototypes: static prototypes and dynamic prototypes. So using testing, we validate the dynamic prototype, not testing, and static prototypes are inspected using static verification methods. Software inspection involves people examining or analyzing the source representation with the aim of discovering anomalies and defects. Inspection not require execution of system, so may be used before implementation. So generally, we can say inspection is conducted before implementation. And why we do inspection? Because we will let less and less errors or defects be injected in the software. So if less and less errors are injected, defects are injected in the code, so laterally it will be easier for developers to implement the correct software. So the inspection purpose is to reduce the chances of errors and defects before implementation. And good inspection is that inspection team and inspection process is that which discover more and more defects before implementation. They may be applied to any representation of the system. Inspection have been shown to be an effective technique for discovering program errors. And one more thing, not only documents are reviewed for inspection, but program, the classes, the object classes, program, the design of program syntax can also be statically verified through inspection before implementation. Advantages of inspection: during testing, errors can hide other errors. Because inspection is a static process, you don't have to be concerned with interaction between the errors. Incomplete version of the system can be inspected without additional cost. So this is the big advantage, that we don't need independent tester on a high wages. So the cost is reduced. More and more defects can be found using the inspection. If program is incomplete, then you need to develop specialized test harness to test the parts that are available. As well as searching for program defects, an inspection can also consider broader quality attributes of the program, such as compliance with the standards, portability, and maintainability. Both inspection and testing should be used during verification and validation process. Inspection can check conformance with the specification, but not conformance with the customer real environment requirements, and real requirements can be checked only dynamically using the validation or testing. Inspection cannot check, this is a big disadvantage, Inspection cannot check the non-functional requirements such as performance, usability, availability, and security, etc. And that can only be dynamically verified using testing. A model of software testing process. This is a generic model. First, you design test cases. What is test cases? Test cases, in short or brief, is that which include all the steps of the test. Means, for example, test identifier number, which module should be tested or which requirement should be tested, the testing type, the testing level, testing category, the input of the tests, the expected output of the test, and then at the end the real output. So test cases are designed, and then based on this test cases we prepare test data. So prepare, this is rectangle is for the preparation of test data. So based on the test cases we prepare test data, and then based on the test data we run the program with the test data and we generate the results, and then we compare the results to the test cases. And in test cases we already wrote the expected output. So expected output and the real output are compared. More and more deviation in the results show more and more errors or faults or defects, and then test reports are generated. So this is a generic testing process model, testing model. Now come to discuss about the stages of testing. Development testing, where the system is tested during development to discover bugs and defects. Remember that there is a difference between terminologies. So bug, when we say about the bug, it is from the developer perspective. So during unit test, when you test a particular piece of code or class objects, so we can find the bugs. A developer find the bugs. Release testing, where a separate testing team tests a complete version of the system before it is released to the user. And user testing, where users or potential user of this system test the system in the real environment. Or user testing is also called user acceptance test or acceptance testing. So the development tests include the unit test, component test, integration test, release testing, and then user testing. Now come to discuss the development testing. Development testing include all the testing activities that are carried out by the team developing the system. Unit testing, where the individual program unit or object classes are tested. Unit testing should focus on testing the functionality of objects, methods, etc. Component testing, where several units or classes are integrated to create a composite component. Sometimes units are the components, and some people call both unit and component as either component or unit, but unit are the minute particle or piece of code that cannot be further divided, and the purpose is same. So where the several units are integrated to create a composite component or big unit, or we can say component is a big unit or a unit which can be further divided. Component testing should focus on testing the component interfaces. So in component testing the focus is more on interface level, because through interface we combine different units. And system testing, where some or all of the components in the testing systems are integrated and system is tested as a whole. This means units comprise component and component comprise the system. System testing should focus on testing component interactions behavior. Unit testing is the process of testing individual components in isolation. It is a defect testing process. Units may be individual functions, methods within object, object classes with several objects and methods, composite components with defined interfaces used to access their functionality. Object class testing. Complete test coverage of the class include testing all the operations associated with an object, setting and interrogating all the object attributes, and exercising the objects in the possible states. Inheritance make it more difficult to design object classes test as the information to be tested is not localized. The weather station object interface, this is the example. Different function attributes are used, so we can test this unit. Now, weather station testing need to define test case for report weather, calibrate, test, startup and shutdown. Using a state model, identify sequence of state transition to be tested and the event sequence to cause these in transition. For example, shutdown, and then we start running and then shut down. So we check different conditions here to validate this particular unit. So this is the example. Automated testing. Whenever possible, unit testing should be automated using some particular tool. In automated unit testing, you make use of test automation framework such as JUnit to write and run your program. Unit testing framework provide generic test classes that you extend to create specific test cases. They can then run all the tests that you implemented and report, often through some GUI on the success of otherwise on test. Now, there are several advantages of automated testing. The first advantage is that manual testing can be biased. Automated testing is not biased. Second advantage is that time consumption. Manual testing consumes too much time. Especially when we talk about the unit test, this whole software comprises of hundreds and thousands of units. So testing again and again, especially in case of agile process, when we follow agile, changes are expected at any time, and after changes we do again and again the unit tests. So it becomes very much difficult and time consuming process. So we then adopt the automated testing approach. Automated test components, a setup part where you initialize the system with the test case, namely the input and expected output as I stated. A call part where you call the object or method to be tested, and an assertion part where you compare the result of the call with the expected result. If the assertion evaluates to true, the test has been successful. If false, then it has been failed. Choosing unit test cases, the test cases should show that when used as expected, the component that you test does what it is supposed to do. If there are defects in the component, these should be revealed by the test cases. This leads to two types of unit test case. The first of these should reflect normal operation of the program. The other kind should based on the testing experience on which where problem arises. This again similar to the validation and testing. The goals of there are two goals of the testing. First is to check the regular operations, and second is to explore more and more defects. So we give developer give more and more dynamic inputs and check the behavior of the code. Testing strategies. Partitioning testing, where you identify a group of inputs that have common characteristic and should be processed in the same way. You should choose test from within each of these groups. Guideline based testing, where you use testing guidelines to choose test cases. These guidelines reflect previous experience of the kinds of errors that programmers often make when developing components. This means the experienced developer will make less and less errors, because he already know that what should be written and what should not be written. So guideline should be taken from either software engineering course or from the past projects or experienced senior developers. Partitioning testing, input data and output results often fall into different classes where all the member of classes are related. Each of these classes is an equivalence partitioning or domain where the program behaves in an equivalent way for each class member. Test case should be chosen from each partition. Equivalence partitioning, this is the system, this is the output partitions, this is the input partition, possible inputs, possible outputs, and this is the system. So what is partitioning? Again, input and output results often fall in different classes. Each of these classes is an equivalence partitioning or domain where the program behaves in equivalent way for each class member. Test should be chosen from each of these class. This is the equivalence partitioning. For example, one partition is less than 4, between 10 and 4, more than 10, and the output should be in this range for less than 4, between 4 and 10 output should be in this range, and more than 10 output should be in this range. Testing guidelines: test software with a sequence which have only a single value. Use sequence of different sizes in different tests. Derive tests so that the first, middle and last elements of this sequence are accessed. Test with a sequence of 0 length. So these are the few more guidelines. Component testing: software components are often composite components that are made up of several interacting objects or units. For example, in the weather station example, the reconfiguration component include objects that deal with each aspect of the reconfiguration. You access the functionality of these objects through the defined component interface. Testing composite component should therefore focus on showing that the component interface behaves according to its specification. Interface testing: objectives are to detect fault due to interface errors or invalid assumption about the interface. So we can also check the interfaces or interface types: parameter interface, shared memory interfaces, procedure interfaces, and message passing interfaces. Parameter interface include data passed from one method or procedure to another using interfaces. Block of memory shared between procedure or function. In procedure interfaces, subsystem encapsulate a set of procedure to be called by other subsystems, and message passing interface includes subsystem request services from other subsystems. So you design a test cases for interface testing, and then you validate a system using the interface. So problem can be in interface designing or development. Interface error: interface misuse. A calling component calls another component. Remember that we call the component from the interface. So it is also possible that component works correctly and it is okay, but interface call a wrong component and makes an error in its use of interface. For example, parameter in the wrong order. Interface misunderstanding: a calling component embeds assumption about the behavior of called component which is incorrect. Timing error: the called and the calling component operate at different speeds and out of date information is accessed. Now these are few guidelines of interface testing. Design tests so that parameters to a called procedure are at extreme ends of their ranges. Always test pointer parameter with the null pointers. Design tests which cause the component to fail. Use stress testing in a message passing system. In a shared memory system, vary the order in which components are activated. Now system testing. System testing during the development involves integrating components to create a version of the system and then testing the integrated whole system as a one unit, one largest unit. The focus in system testing is testing the interaction between the components which comprise the one system. System testing checks that the components are compatible, interact correctly or integrated in a right way, and transfer the right data at the right time across the interfaces. System testing tests the emergent behavior of the system. Now, system and component testing. During the system testing, reusable components that have been separated, developed, and off-the-shelf systems may be integrated. Means the existing old system are integrated and newly developed components. The complete system is then testing. So this means if the system is, for example, comprised of 5 components and we already have tested the 5, dynamically tested, completely tested the 5 individual components, then we also must have to test these components as a whole as a system test. So this means the 5 individual components when integrate, then it comprises the whole system, and then all the integrated modules or components should be tested as a whole. Components developed by the different team members or sub-teams may be integrated at this stage. System testing is a collective rather than an individual process. Remember, this is the main point. In some companies, system testing may involve a separate testing team with no involvement from designers and programmer, because if we include a designer or a programmer in a testing team, the testing process can be biased. So because no developer can compromise his or her own code or design, so the better option is to keep the testers independent, and the best approach is to hire the independent team from outside the company that have no friendly relation with the developers. Use case testing. The use cases developed to identify the system interactions can be used as a basis for a system testing. As when we draw the use cases, the purpose of use cases is that how user interact with the system. So at the end, we can say that use cases show the high level user requirements or features, and features are comprised of many components, or we can say that the few use cases reflects the whole system, and then we can validate the system testing, or we can do the whole system testing from the using the use cases. Each use case is usually involves several system components, so testing the use case forces these interactions to occur. The sequence diagram associated with the use case documents the components interaction that are being tested. This is the sequence diagram. So all the use cases included in this are tested in sequence. And the purpose of drawing the sequence diagram was that how the system will perform in the sequence. So we then test the whole system in a sequence. If sequence is not okay, this means there is a fault. Test case is derived from sequence diagram. An input of the request for report should have an immediately associated acknowledgement. So as like the use cases, we can also derive the test cases from the sequence diagram. Sequence diagram shows all use cases in the sequence. So testing policies should be adopted. Examples of testing policies include all system functions that are accessed through the menus should be tested. Combination of functions where the user input is provided, all the function must be tested with both correct and incorrect policies. This was all about the basics of the testing. In next lecture, I'll